Good morning. In 5 minutes, we are starting the class. हो गया प्रिपरेशन सब कुछ? Now let us start. See the first topic, which is the most important. The first point, that is basic proportionality theorem. Now this theorem can be asked the theoretical part plus one numerical, or directly it can be asked in the form of numerical. Now this is also named as Thales theorem, right? So this will be applicable when any two lines are online or any two lines are parallel. We will use the BPT theorem. Now see, what does the theorem say? First I am writing the statement and then explaining. If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct point. The other two sides are divided in the same ratio. Now what does that mean? Okay, if I am making a parallel line to one side of the triangle, suppose this is my triangle ABC and this is DE, which is parallel to one side. And so it says, okay, if I do this, so it will divide the triangle into two equal parts. So, or the ratio will be, we need to prove AD upon DB equal to AE upon EC. Now, see, first we will need to do some construction, that is we will be joining BE and DC. And then I will be making like this perpendicular. So, construction, what I did, join BE and CD are drawn DM perpendicular to AC and EN perpendicular to AB. And see, don't worry, I will be sharing with you the whole PPT. Like that day, the whole PDF I will share in the group. So just now be careful here. Now, see how I can prove this. So proof. Area of triangle ADE. Area of triangle is half into base into height. So same way that will be half into AD into EN. I have taken AD as base, right? And area of BDE triangle will be same way half BD into EN, right? Then area of triangle BDE, can I write like this, half into DB into EN? I can write both the ways, whether I write BE or DB. It doesn't make any change. Now, then area of triangle ADE will be equal to half into AE into DM, and area of triangle DEC will be equal to half into EC into DM. Now, see, moving ahead in this, so I can say area of ADE upon area of BDE will be equal to half AD into EN, equal to half into AD into EN whole upon half into DB into EN. So see, half cancel, EN cancel. So I got AD upon DB. So this will be my first number. Same way, area of triangle ADE upon area of triangle DEC will be equal to half into AE into DM upon half into EC into DM. So again DM cancel, half cancel. So I got AE upon EC. This is 2. So, and area of triangle BDE equal to area of triangle DEC. Right, that is third. As both are on the same base and between the same parallels, so they will be equal. So, can I say from 1, 2 and 3, AD upon DB equal to AE upon EC. So, now see, if I add in on both the sides plus 1, see, so can I write AD upon DB plus 1 equal to AE upon EC plus 1. So, therefore, it will become AD plus DB upon DB equal to AE plus EC upon EC. So, AD plus DB is AB upon DB, and AE plus EC will be AC upon AE. So, I got both the things proved. So, this is the basic proportionality theorem. Clear? Any doubt in this? Just show your thumbs up if you have understood. Now, see, moving ahead, now the next is converse of this thing, converse theorem, that is converse of BPT. So that is also important because on that basis also they ask us the sums. So converse of BPT. Now, what does that says? Let us first discuss that. Okay, see, it says, okay, if a line divide, first let me write it. If a line divides any two sides of a triangle in the same ratio, prove that it is parallel to third side. See, now what it is saying, K, before it was given K, it is joining the midpoints and prove that it is parallel. Now it is showing the reverse one, K, it is parallel. So show that, it is touching the same points, 2 points. So prove that K, it is parallel. So see, if I draw a figure again, the same figure will be here also. See, A, B, C. Now DE I am doing. But the only thing is, now it is said in same ratio. That means this and this is equal, same to this and this. So I need to prove that DB equal to DE is parallel to BC. So see, here I will do the contradiction method. I am taking some DF point which is the center. So see, now construction what I am doing, I am not writing to prove because that is given, and to prove I have not written here. So construction is saying okay, if DE is not parallel to BC, so then make DF parallel to AC. See, this we are constructing. Okay, DF is now we say okay, DF is parallel to AC. So therefore, using BPT, can I say AD upon DB equal to AF upon FC? This should be there, the first point, because already it is saying that they are dividing it into equal points to prove this. So that will be there. But see, I am given what? AD upon DB equal to AE upon EC. This I am given. So this is 2 number. This is given to me already. So from 1 and 2, AF upon FC equal to AE upon EC. Now see, left hand sides both are equal. So I would say RHS sides will also be equal. Now again, I am doing the same thing. I am adding 1 on both the sides. So see, AF upon FC plus 1 equal to AE upon EC plus 1. So therefore, AF plus FC upon FC equal to AE plus EC upon EC. So I can say therefore AC upon FC equal to AC upon EC. Now see, AC both sides are equal. So can I say therefore FC equal to EC? So FC will be equal to EC. So if FC equal to EC, if that is there, that means what? Okay, therefore E and F are the same point, because then only it will be possible. If both points coincide with each other, then only I can say it is that. Clear? Any doubt in this? Okay, now moving ahead. See, next theorem. See, first I am doing all the theorems which are important, then I will be moving to the sums, the important sums or the expected sums which can be asked. And don't worry, I will share the whole PDF, and up in the afternoon you will be able to see the video of the same again if you want to see. Now, see, then from circles chapter, one theorem is very common, that is prove that. See, let me make little bit thicker pen so that if you are not able to see, you can see it. Prove that the length of tangents drawn from an external point to a circle are equal. That means this is which one? See this one. Okay, this is a circle with center O, and from T point I am doing two parallels. Oh, sorry, tangents which touch it at P, and let it be this point be Q. It is touching here. So if I draw it here, so it will be 90. If I draw a line from the center, it will be 90. This is P point and this is T point. And I will be joining TO. This theorem. See, this is very common and it is asked almost every year. So it will have 100% chance that this theorem will be there, or a sums based on this. Now see here, what is the given thing to me? PT and TQ are two tangents drawn from an external point T to circle with center O and radius R. So now to prove is what? To prove he is saying us to do K. He is asking us angle OPT equal to angle OQT. Oh, sorry. This is the first theorem. So it will be PT equal to TQ. We have to prove that they are equal. So, see, proof. A tangent to the circle is perpendicular to the radius. See, this was the basic thing. If I draw any radius to the tangent, it will be always perpendicular at the point of contact. So therefore I can say angle OPT equal to angle OQT. So, and see, OT equal to OT is common. This is common given to me. So, can I say angle OPT equal to angle OQT equal to 90 degree, because we first said it will make 90 degree. The angle of tangent and radius will be 90 degree. So, and OP and OQ are radius, so they will be equal. So therefore, can I say triangle OPT congruent to triangle OQT? This is which rule? RHS congruence rule. So using that rule, I proved both the triangles congruent. Once I proved both the triangles congruent, so therefore what I will say, KPT equal to PQ. CP. Clear this one? See, these are the most important theorems which we are doing just now. So clear? Any doubt in this? Okay, moving ahead. Now see, next theorem is somewhat related to this only. It says, see, prove that the tangent at any point of a circle is perpendicular to the radius through the point of contact. Now, we need to prove it is perpendicular. See, let this be. Now imagine that it is a circle and we need to prove that this is 90 degree. See, if you see the circle and or the figure, see, can I say OA equal to OC because both are radius r, right? Now, OB will be equal to OC plus BC because it is having 2 points. C, O to C one line segment and B and C line segment. So it is made up of 2 line segments. So now moving ahead, see, so therefore I can say OB is greater than OC because when I am adding BC in OC, I am getting OB. So therefore OA is less than OB and B is an arbitrary point on the tangent. Thus, OA is shorter than any other line segment joining O to any point on tangent. Therefore, shortest distance from the center, shortest distance of a point from a given line is the perpendicular distance. So I can say K tangent at any point of circle is perpendicular to the radius. Understood? Arbitrary point means any other point on the circle that is not on the it is not on the circle, it will be outside the circle, so it is on the line, that tangent line. That's why we use the arbitrary word. Clear? Now, see, moving ahead, now I am taking some of the sums based on this. See, these are the basic theorems which are always asked. So that theorems I have taken. Now I am taking some basic sums which are many times asked. So you can say that they are the expected sums that can come. So the first one is, see, in the figure given, DB perpendicular to BC, DE perpendicular to AB, and AC perpendicular to BC. Prove that BEDA equal to ACBC. See, now here diagram if I draw, it is something like this. See. Now, here let angle ABC equal to theta. So, this I am taking one number. Therefore, angle DBE will be 90 minus theta. So, in triangle DBE, angle BDE plus angle DEB plus angle DE will be equal to 180 degree. This is what angle sum property of triangle. So that I have used directly. So angle BDE will be equal to 180 degree minus, see, which angle we have taken 90? ABC equal to theta and DBE equal to 90 minus theta. So can I say 180 minus 90 because DBE minus 90 minus theta. So this will be equal to, if I cut 90 and 90 minus will get cut. So I will get 180 minus 90 minus 90 minus 180 and plus 180 will get cut. And minus of minus theta, theta. So this second I got K angle BDE is also theta. Now in triangle DBE and triangle ABC, angle DEB equal to angle ACB equal to 90 degree. This is given, right? Because it is told perpendicular. Then angle BDE equal to angle ABC. So this is I am getting from 1 and 2. So therefore I can say a triangle DBE similar to triangle ABC. So therefore DEBE equal to ACBC. See, now based on BPT and based on this, there is one sum which is almost asked every year. It comes whether it is basic or whether it is standard. See, if you see the old question papers, you will see this sum very common. See, let us discuss that sum now. In figure, considering triangle BEP and triangle CPD. Prove that BP into PD equal to EP into PC. See, now if I draw diagram, you will say, yes sir, we know this one. See, this diagram. And if you remember in, I think in half yearly also this sum was there. So, see what is given here first. I am given triangle ABC in which BD is perpendicular to AC and CE is perpendicular to AB, and BD and CE intersect at P. To prove, he has given me this statement, BP into PD. So BP into PD, BP into PD equal to EP into PC. This I need to prove. Now, proof how I will do. See, in triangle EPB and triangle DPC. See, angle PEB equal to angle PDC because both are 90 degree. Clear? Both are 90. Yes, it is there in half yearly paper also, and it is the textbook sum. So that is asked every time. That's I have taken that. Now angle EPB equal to angle DPC. This is vertically opposite angle. That is, we call it as VOA. So by AA criterion, right? And AA criterion is for similarity. So can I say triangle EPB similar to triangle DPC? So therefore EPDP equal to PBPC. So therefore if I bring BP into PD, so that will be EP into PC. Or see, even he can ask me like this, BP upon EP equal to PC upon PD. Many times he asks like this or this. Both the ways are the same. The sum is same. Only the way of presentation will differ here. Clear this sum? Any doubt in this one? Then moving ahead, see, the next sum is also an important sum and it is asked many times and it is very common sum. See, in figure, if the line segment DP intersects the side AC of a triangle ABC at point E such that E is the midpoint of CA and triangle AEF equal to triangle AFE. Prove that BDCD equal to BFCE. See, now here the figure is something like this given. This is B, here one point is C and this is D. And from here one line goes like this, it touches here at A, and from D, oh sorry, from D it goes like this. This is F, this is E. Now, proving this sum, see, first given thing is DF intersects AB at F to triangle ABC. Now, angle AEF equal to angle AFE. Then to prove it is BD upon BF equal to CD upon CE. See, now if I start the proof as given, E is the midpoint of CA, then CE equal to AE. So this is first equation. Now also angle AEF equal to angle AFE. So this is second equation. Now therefore I can say KAE equal to AF. This is my third equation. See, from 1 and 2 we get CE equal to AE. See, first was CE equal to AE, second was AE equal to F. So can I say CE equal to AE equal to AF? So therefore I can say CE equal to AF. So this is my fourth equation. Now let us draw a parallel from CDF. So as we know that corresponding angles are equal, so therefore angle AFE this is fifth equation. Now and angle AFE equal to angle AGC, sixth equation. So from equation 2, 5 and 6, angle AEF equal to angle AFE equal to angle ACG equal to angle AGC. So from above contradiction, we will get that AC equal to AG. So this is 7. That means AE plus CE equal to AF plus GF. So therefore I can say KAE, oh sorry, this though already I have done. Now, so therefore CE equal to AF equal to GF. This is eighth equation. Now, using BPT theorem, can I say BC upon CD equal to BG upon GF? So, if I add 1 on both sides, so BC upon CD plus 1 equal to BG upon GF plus 1. So, I will get BC plus CD upon CD equal to BG plus GF upon GF. So therefore BD upon CD equal to BF upon GD. So therefore BD upon CD equal to BE upon CE. Hence I have proved. Now next sum is again an important sum which is every now and then asked. Okay, it is very common sum which is asked every time. So let us understand that sum also. See, it says in figure a point O inside triangle ABC is joined to its vertices from point D, AO, DE is drawn parallel to AB, and from a point E on BO, EF is drawn parallel to BC. So you have to prove that DF parallel to AC. Now see, whenever parallel comes, we understand that it is BPT. So what is given to me? See, a triangle ABC in a point O. See, so this is O. Now it is joined like this. See. Now he is saying then he is joining, see, this 3 points like this. Remember this diagram now. D, E, and F. Now he is asking me to prove this. See, in triangle OAB, DE parallel to AB, that is given. So, using BPT, can I say OD upon DA equal to OE upon EB? 1. And how I got BPT? Now, in triangle OBC, EF is parallel to BC, that is also given. So, therefore again BPT, so OE upon EB equal to OF upon FC. This is 2 number, again BPT. Now see, if you see the 1 and 2 equation, so can I say here OE upon EB is coming equal? So from 1 and 2, can I say OD upon DA equal to OE upon EB, and that is equal to OF upon FC. This is there. So therefore OD upon DA equal to OF upon FC. So now D and F are points on sides OA and OC of triangle OAC such that OD upon DA equal to OF upon FC. Now moving ahead, so if this is there, so DF is parallel to AC, converse BPT. converse of BPT theorem. So I got my answer. Any doubt till here? Now, moving ahead, see, moving ahead, there is one more sum of the same pattern which is asked every time. See, almost every year we see in one or the other papers out of the three sets. See, that is in given figure. See, figure is this one, so you will understand which sum I am asking. Two triangles BAC and triangle BDC, right angled at A and D respectively, are drawn on the same base BC and on the same side of BC. If AC and DB intersect each other at P, prove that AP into PC equal to DP into PB. Now, see, I think this is also a textbook sum. So here if I want to prove this one, see, I can do it in an easy and short way. Okay, in triangle APB and triangle DPC, angle A equal to angle D equal to 90 degree. Angle APB equal to angle DPC. See, VOA, vertically opposite angles. APB, this angle, and DPC, the marked angle. Using AA criterion of similarity, can I say triangle APB similar to triangle DPC? So, APDP equal to PBPC. So, therefore, AP into PC equal to DP into P. Hence, proved. Now, next sum is also based on this. See, from the triangles chapter, there are only two topics which they ask basically on which the sums are coming. The one is BPT and one is similarity criterion. So you should know all the similarity criterions and BPT. So from that only they are asking. So let us move on to the next one. It says in figure P is the midpoint of BC and Q is midpoint of AP. If BQ when produced meets AC at R, prove RA equal to 13CA. So this is the figure which is formed. Now here in triangle ABC in which P is midpoint of BC, Q is midpoint of B of AP, such that BQ produced meets AC at R. Now construction, what I am doing, draw PS parallel to BR using meeting AC at S. So see, now parallel came, that means I have to go for BPT. So to prove is given to me, I have to prove that RA equal to 13CA, 1313CA. So proof. In triangle BCR, P is midpoint of BC and PS parallel to BR. Therefore, S is the midpoint of CR. In triangle APS, Q is midpoint of AP and QR parallel to PS. Therefore, R is midpoint of AS. So, therefore, AR equal to RS. And from 1 and 2, I can say AR equal to RS equal to SC. So therefore AC equal to AR plus RS plus SC, which is equal to 3AR. So therefore AR equal to 13 AC, which is equal to 13 C. Now, next sum is also from similar diagram which was there before. See, it is like this given. This value is given x, this is y, and here it is PQ Z. So here he is asking us to prove 1 upon x plus 1 upon y equal to 1 upon x. So he is asking us to prove that this 3 is there. So here in triangle ADB and triangle PDQ, AB parallel to PQ. So therefore angle ABQ equal to angle PQC. Corresponding angles, angle ADB equal to angle PDQ common. So by AA similarity, criterion, triangle ADB similar to triangle PDQ. So therefore DQ upon DB equal to PQ upon AB. So therefore DQ upon DB equal to Z by X. This is first. Similarly, triangle PBQ similar to triangle CBD and BQ upon DB equal to Z by X. So 1 plus 2 implies Z by X plus Z by Y equal to DQ plus BQ upon DB, BD upon DD. So therefore Z by X plus Z by Y equal to 1. So therefore I can say 1 upon X plus 1 upon Y. If I take Z common from both, see I have taken Z common, equal to 1. So therefore 1 upon x plus 1 upon y equal to 1 upon z I brought on right side in the denominator. Now one more important sum which is every now and then asked from this chapter, that is in figure. See, figure is this one. Angle D equal to angle E is given, and AD upon BD equal to AE upon EC is given. So prove that triangle BAC is isosceles triangle. So see, figure I have already shown. Now here what is given to me? Angle D equal to angle E. This is given, and the other thing AD upon DB equal to AE upon EC. So these two things are given. So see, can I say in triangle ADE angle D equal to angle E is given. So therefore AD equal to AE. First, both will be equal. Now AD upon DB equal to AE upon EC is there. So therefore I can say DB upon AD. If I reverse both of them, so that will be EC upon AE. I have just done reciprocal of both, and now I am adding 1 on both sides. So therefore DB upon AD plus 1 equal to EC upon AE plus 1. So this will be DB plus AD upon AD equal to EC plus AE upon AE. So DB plus AD will be BA upon AD, and EC plus AE is CA. So CA upon AE. So therefore BA upon AE equal to CA upon AE. See why I have done this? I have used equation 1, AD equal to AE. So instead of AD I have written AE using equation 1. So this means now both sides AE is there, so I can cut them. So therefore BA equal to CA. So therefore triangle ABC is isosceles triangle. So I got that the triangle is isosceles, which they needed to prove. Now see, from this chapter only he shows us one more pattern of sum. No, now it is not there. This was the last one. Now see, coming to the quadratic equations. See, coming to the quadratic equation, then we will be going to circle chapter at the end. So see, one common sum which he asked is find the value of k's, right, for each of the following quadratic equations. So that they have equal solution. Now equal solution means what should be there? Equal solution. What is the condition for equal solution? Yes, it is important. That's why only I am showing you, beta. See, now first one is 2x square plus kx. This is A. There are two equations given in this. The B1 is kx into x minus 2 plus 6 equal to 0. So see how I can solve it easily. Okay, if I solve the A1 first, see equal roots means equal roots. So therefore D will be equal to 0 discriminant. So B square minus 4AC should be 0. Here in the first equation A is 2, B is K and C is 3. So, oh sorry, I forgot to write C. C equal to 3. So, therefore, B square minus 4AC will be B is K, so K square minus 4 into 2 into 3. So, this should be equal to 0. So, 0 equal to K square minus 6 for the 24. Right? So, therefore, can I say K square equal to 24? So, therefore, K will be equal to plus or minus root of 24. So, if I take out root of 24, so it will be plus or minus 2 root 6. 12 to the. So, from or 6 for the 24. So, that also I can use. So, I have used 6 for the. So, 4 I have taken out. So, 2 6 the. Then, B1. See, it is given to me kx into x minus 2 plus 6 equal to 0. So see, first if I bring it in the proper form, so this will be kx square minus 2kx plus 6 equal to 0. Now if I compare with the standard form, ax square plus bx plus c, so a equal to k, b equal to minus 2k and c is 6. So again b square minus 4ac will be equal to 0 because it is having equal root. So therefore minus 2 whole square minus 4 into k into 6 will be equal to 0. So 4k square equal to 24k. So if I cut k on both sides and 4 on both sides, so see k will be equal to 6. I will get. So if these are the values, then it is said that it is the solution. K's value I can have this much. Now from quadratic one more pattern of sum is asked. See, okay, where x is given and they ask us the value of k. So see, I am taking one example for that. If x equal to minus 1 by 2, I am writing it in bracket so that you understand, is the solution of the quadratic equation 3x square plus 2kx minus 3 equal to 0. Find the value of k. See, x equal to minus half. So therefore, if I substitute x equal to minus half, so 3 into minus 1 by 2 whole square plus 2k into minus 1 by 2. So 2 cancel here and minus 3 equal to 0. So 3 by 4 plus minus k. See, 3 by 4 minus k minus 3 equal to 0. So can I say 3 upon 4 minus 3 equal to k? So 3 minus 12 upon 4 equal to k. So k equal to minus 9 by 4. Then one more pattern of sum is every year it is asked. See, okay, where it says root of 2x plus 9 plus x equal to 30. Something like this will be given to you and you will be asked to solve. So, how I can solve this? See, if I do squaring on both sides, so I will be having problem again. I will get a square because 2ab I will get. So first what I am doing, I am taking x on this side. So root of 2x plus 9 equal to 13 minus x. Now I am squaring on both sides. Squaring both sides. So can I say root of 2x plus 9 whole square will be equal to 13 minus x whole square? So 2x plus 9 I will get on this side. Here it will be 169 minus 26x plus x square. So if I bring everything on one side, so what I will get? X square minus 28x 169 minus 9, so 160. So plus 160 equal to 0. Now 160's factors I have to do such that the sum should be minus 20. So can I say minus 28? So x square minus 20x minus 8x plus 160 equal to 0. Now from the first two I am taking x common, so x minus 20. Now from second two I am taking minus 8 common, so equal to 0. So can I say x minus 20 into x minus 8 equal to 0? So either both can be 0 or any one can be 0. So x will be 20 or x will be. If I bring minus on the other side, it will become plus. So I got two solutions. One is x equal to 8, one is x equal to 20. Clear this one? Any doubt till here in the quadratic? Shall I move ahead? What happened, Deepika? What you didn't understood here? Okay, no doubt. Okay, so let us do one more sum of the same pattern. See, now one common sum every time is asked, a plane left or train went and that one. So I am taking one sum of that pattern also. See, a plane left 30 minutes late from schedule. And in order to reach the destination 1500 kilometer away in time. Now see, it wants to reach on time. So what will happen? It needs to increase the speed. So it increased its speed by 100 kilometer per hour from the usual speed. Find the usual speed. So see, now it came x plus y and that one. The if I say, so I can say river and current pattern sums. So see, I don't know the usual speed, so let us suppose it as x. So let usual speed be x kilometer per hour. So speed taken, that is afterwards what speed it took, kx plus 100 kilometer per hour, it increased because it increased 100 kilometer per hour. So distance is 1500 kilometer. So can I say usual time will be 1500 upon x hours, and time taken, actual time taken was 1500 upon x plus 100 hours, because already it is given 100 over speed it increased. So and the difference is 0.5 over, so it reached half over. So time taken will be, so the equation which I will form will be 1500 upon x minus 1500 upon x plus 100. I reached half over early, so half over I am showing like 1 by 2. So if I solve this ahead, so see, I am doing LCM first. So what I will get, x into x plus 100. So 1500 into x plus 100 minus 1500x equal to 1 by 2. So this will be 1500x plus 1500 and 2 more zeros minus 1500x whole upon x square plus 100x. So now this 1500x got cancelled now into 2. So can I say, if I solve this equation, can I say x square plus 100x minus 3 lakh equal to 0? See, I cross multiplied and I brought everything on one side to make my equation shorter. Now I am using alpha beta formula, that is root formula, discriminant one. So x will be equal to minus 100 plus or minus root of b square. So 100 square minus, oh sorry, plus 4 into a and c, minus 4 into a and c. So it will become plus 4 into 3 lakh upon 2a. So 2, so this will be minus 100 plus or minus 110. Oh sorry, 11. 1100 will go upon 2. So if it is plus, then minus 100 plus 1100 upon 2, that is 1000 upon 2. So that will be 500 kilometer per hour speed it is there. If it is minus, so minus 100 minus 1100 upon 2. But minus is not possible because I can't say okay, minus 600 kilometer per hour speed will be there. So the actual speed is 500 kilometer per hour. So this is my actual answer. This won't go because mine speed can't be negative. Now, see, here I am stopping just now and we will continue the same in the evening at 5. Right? Any problem to join at 5 o'clock? Any problem to join? So, shall we meet again at 5? So, 2 hours in the evening. Okay, no problem. So, we will meet at 5 o'clock in the evening. Right? Bye, everyone. And I am sharing this file in the group. In evening I will share. Just now I will, or you want me to share just now? Okay, I am sharing just now. Come on, no problem. Bye.